what we're going to talk about today is we're going to talk about AI. And there's all these people that are promising you AI is going to solve all your issues and everything will be better. Everything will be wonderful. AI, you'll do things better, faster, easier. The answer, the reality is it won't always. To get better results from AI, you need to combine domain expertise, functional expertise, and AI expertise. And that's the core theme of the talk we're going to have today. We'll cover in the talk some new and I think fascinating research on AI for innovation, which shows you that AI can actually be as creative or more creative than human beings. We'll talk about two important innovation methods, TRIZ and innovation sprints, and we'll put AI to the test in a practical case, which I think is really fun. And it's actually Richard's idea to test it with something from the 1930s. And you'll learn how to boost TRIZ and other innovation methods with AI to deliver better results, faster, easier, and wickedly fast. A question you might have is, who are we to talk? And we'll do a quick introduction. I'm Bryan Cassady. My background, I'm what you would call a serial entrepreneur. I did 11 companies, 6 different countries. I have 8 exits along the way. About 10 years ago, somebody asked me to teach, and I said, who wants to teach? And actually, I found I really, really enjoy teaching. I've taught at the world's leading accelerators, the largest
you know that, right?
program in Europe and the largest worldwide. And I've taught at leading universities like Stanford, Berkeley, London Business School, and the leading entrepreneurship program in Europe. But I've taken a shift in life, and that's gone from teaching the fortunate few to the motivated many. And I'm on a mission to train 1 million innovators by 2027. This number is updated. I said I have 5,000 this year. It's actually about 2,000 this year. But even at this rate, it's going to take me 100 years to reach my target. And the way I'm trying to get there is through books, courses, sprints, events like this where people come and sign up for other stuff. Richard, you're up.
Hi, my name is Richard Langevin. I'm the CEO and principal of Technical Innovation Center. We started our business back in 1995. We've published 5 books on the subject, and we do a lot of training. We've trained hundreds of companies and hundreds of people in order to be able to use TRIZ competently and confidently. Over 30 years of work. I'm really excited about joining up with Bryan and Wojciech in order to bring TRIZ and AI together. For me, AI is an exciting new S-curve in the evolution of TRIZ, and will elevate TRIZ to a high level and make it a lot easier for people to be able to use and appreciate. TRIZ is really the backbone of problem solving, and most people just don't take the time or the effort to really learn about the methodology. They get tired and quickly abandon it for some reason. Wojciech, how about you now?
So I'm Wojciech. It's very nice to see you all. I'm actually innovation enthusiast and researcher, and my love for innovation started during my university times. When on the first degree I studied mechanical engineering and I had patent application back then. And on my master's degree I did master thesis about management of ideas. And for my everyday job, I'm marketing manager, and I'm cooperating here with Bryan because I also felt some love for education. And I will start this presentation because today we will present you the method, the test and proof, and at the end there will be a space for your questions, of course, some Q&A session. And what's on agenda today? So on the first part, we will tell you how working with AI helped support the innovation efforts and how to do it smart. So we will tell how to work hand in hand with AI instead of hoping that it will do it all by itself, because clearly it won't. Without your expertise, it wouldn't be able. So after that, Richard will tell you about TRIZ, As he already mentioned, it's a very powerful problem-solving method that helped create countless breakthrough innovations. And now it can be enhanced with AI ability to process information at lightning speed. Then I will be back again to add the secret ingredient that makes the difference between accidental and systematic innovation, which we discovered is sprints method, and we augmented sprints, which Bryan will present. The next point we will see a real-life example of genius problem-solving skills behind one of the most impressive constructions in US, and more importantly, how our method compares to that and how we improved the results. But there is something that makes today different, because we are not here to overwhelm you with complexity. And more, we are here to give you practical tools that you can use tomorrow morning. Because in today's world, you don't just need innovation, because you need innovation that works, that delivers, and that you can count on. But let's start, unsurprisingly, at the beginning. So to set the context, we will start with the definition, one of the many, of innovation. Innovation is about things that are meaningful, unique, and they capture value. But in the reality, okay. So in reality, Bryan and I, we've spent almost 8 years of our lives combined researching over 400 companies. Some of them succeed and most failed. And the biggest difference between the winners and the losers was not the quality of their ideas, but that the winners were able to start with mediocre ideas and make them great over time. The majority of companies have what we would call bad cycles. So the ideas got worse and they generated bad solutions over time. Winners instead build ideas over time, and the process that we've seen, it's that innovation was done cycle by cycle, and hence the name of Bryan's book, Cycles, which I highly recommend, by the way. And so if we look at the cycles as the ABCs of innovation, it's about alignment, so figuring out what we want to do, building something, communicating and checking if it's any good, and systematically improving, which with each cycle to get better and better. It would be nice to think about innovation that they are as easy as ABCs, but they are not. Actually, they are a very iterative process. You might go forward one step or go back 2 steps, but it's the process of continually moving forward and getting things right step by step. The most important thing that we learned was that innovation is it's a product of the parts. So if you get everything right, you get a good focus on where you want to go, you build a big idea, you check them out, and you systematically improve them, then, and only then, you will get bigger, better ideas faster and at lower risk. But if you miss on alignment, what you will get is chaos and wasted energy. If you miss out on building ideas, you will get weak ideas and small improvements. If you missed out on checking the ideas, you will waste a lot of money and a lot of time. And if you don't systematically improve, you will be left with small wins and no big improvements. Bryan, it's you.
So I'm struggling. I like to write when I talk because it allows me to be like, you're back at school and you're talking and sharing things. And I just broke my pen, so I've been fiddling.
Guys, there are bagels too if you'd like bagels.
Actually, Wojciech, can you figure out how to mute everybody?
And then... Yes, I will try. Yeah.
Okay, so
I don't want bagels.
I would like a bagel. So we have two different things we're talking about today. We're talking about innovation. We're talking about AI. And how do the two overlap? Well, actually, Moshe gave you a good introduction to what innovation is about. I'm going to talk to you a little bit about AI and how that fits together with innovation. First, a definition of AI. AI, according to McKinsey, is a machine's ability to perform the cognitive functions we usually associate with human minds. It means acting like people. But when we talk about AI, we're not usually talking about all the areas of AI. AI has predictive neural networks, all these different things. But when we talk about AI today, we're usually focused on what I'll call what's generative AI. Generative AI focuses on creating new and original content. It takes old stuff, lots of old stuff, to guess new stuff. It's essentially a prediction machine. Before we talk about things today and talk about TRIZ, I'd like to give you a few facts around innovation and how it's working. Now, there's a lot of studies out there and a lot of people concerned about the future of what's happening with AI and what's the role of human beings. Now, there's two things on the side here, and let's see if my pen works, and it does not work, so I can't write. Kind of a bummer because I always find it's interesting to write when you compare AIs and human beings, you have two graphs on the right-hand side here. One is comparing the ability of human beings versus AI to create novel ideas. And what you'll see is, in general, AI is better than human beings, but you have a few human beings that are winning in the process. You can also look at the ability to create valuable ideas. And here, because AI is a prediction machine, it's actually better than almost all human beings in terms of making things of value. There's a really cool study, and I would recommend anyone that's here takes the time to download it. It was a study done by the Harvard Business School and the Boston Consulting Group. They did a test taking 758 consultants and gave them AI to work on some creative tasks. They took the consultants and they divided them into two groups: the best consultants, the top half, and the bottom half of consultants. What they did is they had them using AI in some creative tasks. And what they found is both groups got better. The top half got 17% better, and the bottom half got 43% better. But that's not the big thing which is here. Of course, a 20% increase in productivity is truly amazing. But what's more amazing here is the fact that the bottom half and the top half tended with AI to produce results at the same level. Now, one of the things that comes up is when you're looking at AI, people tend to focus on the positive and wonderful stuff about AI. But there's a problem with AI, and that is AI can lead you quickly down the wrong path. What they did, which is really interesting in this study, is they had the consultants work on a challenge which was beyond the skill set of AI and just let them figure out how they're going to do it. There was one group that didn't have AI. They got the right answer 85% of the time. The second group, who could choose or not choose to AI, got the right answer only 40% of the time. In this case, what happened is AI led people to get things wrong 3 times more often. What's even worse is the consultants using AI were more convinced that they developed a good solution. AI is really good at giving you an answer to everything. It's even equally good at convincing you the wrong answer is the right answer. Now, if you want to think about working with AI for innovation, there's a sad thing. I'm not going to give you a secret prompt that unlocks all of AI potential. Effective use of AI is about guiding AI with expertise and working interactively. We're going to take a step back. Now, this used to be true. When you asked AI to give you a random number between 0 and 100, it gave you the answer 42, 15% of the time. Would anyone in the room have a guess why AI would predict the number 42, 15% of the time? The other numbers are 2, 6, and 7, which are overrepresented. If you put something in here, all right, let me give you the answer. The answer is there was a great book out. We got it. Nick's got it. The Hitchhiker's Guide to the Galaxy. So in the Hitchhiker's Guide to the Galaxy, the answer to life, the universe, and everything was the number 42. AI is not actually predicting a random number, but it's predicting what you'd like to see as a random number. This means it's giving you stuff back that you want. What that means in the context of innovation, if you ask AI to just give you ideas, it will typically give you pretty weak and pretty obvious ideas. Your challenge is to break the pattern and to get AI to think differently. The best way I can think of to do this is to use something called CAR, context, action, result. You tell AI to think differently, you tell it how you want to do things, and you tell it how you want to get the results. You've also got more advanced things, which are called, for example, few shot, which is about giving AI an example of what you want, or using chain of thought, which is really the power of AI accelerated many times, which is saying, look, you've given me something, improve on these ideas. So if you look at this, what you'll see is the quality of ideas that you'll get from AI go up based on how you use it. Give me 10 ideas, we'll give you 10 pretty obvious ideas. Give me 10 ideas with detailed objectives. Think like this, do it this way, deliver results in this format. We'll give you better ideas. And the best ideas will come out of saying, look, what I'd like you to do now is analyze those ideas and improve on each one of them step by step. What we're going to talk about for a second is something called mechanical creativity, which is about how with a few clicks you can generate thousands of ideas. We started with this project looking at some past research. The research was done by some people in my alma mater, Cornell University and Wharton University, showing that in fact you can trick AI to create more novel and unique ideas. Better prompts lead to better, more variants. What they didn't show in this study is that you could get the ideas to be better ideas. It just showed that we came up with a question, could even better prompts and methods make AI more creative? We decided to do a study. We took 260 business school students submitting ideas for a challenge as part of a job application. We took exactly the same test that they ran in the initial study. What we tested is students working alone. We had students with AI. We had students with AI in a clear challenge, and we had students with a clear challenge and what I'll call smart AI. Here's the full test to what we did. The first thing we had is we had human beings working alone with no help of AI, humans with no help, no support, no training, but ChatGPT. We had then a group that were given a clear challenge. And what we did is we took the challenge that was there and put it into a different format. Just like human beings, AI works better with a story. When you give context and clarity to what you're looking for, it's better able to connect the dots. Secondly, it works very well with ideas to start. It's like putting, sparks in a fire to get things going. And we've created a framework for that, which we call True North, which is about a story, objective, restrictions, and tactical constraints, which is essentially how you define an innovation challenge. I want this, but I don't want that. So we had that. We asked AI to just give us some ideas, and you'll see that in fact it was better. And then we had something we'll call smart AI. And smart AI is probably an exaggeration because we didn't give it things that were really hard or really complex. We gave it a car. We gave it a context. Think like an innovation expert. For those of you here who know something about TRIZ, we said, what we'd like you to do is generate 80 ideas based on the TRIZ inventive principles for our challenge. For each of these, give us 2 ideas. Essentially, what you need to know is that TRIZ exists, and you need to be able to ask the question, and we asked for the results in a specific format. We did this same type of smart AI with lots of different innovation methods. All of these things work with humans. The question we had is, will it work better with AI? The first one we tried is alternative views. Solve this challenge as if you're Elon Musk. Solve this challenge as if you're Apple or Google. The second one we did is we tried with leading creative tools, the DeBonis 6 Thinking Hats, Scamper, all these other things. My favorite, and even though it didn't win in this test, I still think it's the best way to build really cool ideas, is creative combinations, taking different stimulus, putting them together, and creating a new idea. We had a whole series of less known methods, and we had TRIZ. All of this stuff came together. We tested 81 different smart ways to build ideas. The way that we do this is we have a toolkit, which is up online. And by the way, you can have access to the toolkit. Step number one is you select an idea building method. Step number two, you describe a target. And step number three, you push on a button. And then what pops out is a whole bunch of ideas. They run ideas after ideas after ideas. To give you an idea of how many ideas we generated for our little test, we had 5,402. There was 270 submitted by the students working alone, 310 submitted by students with AI, 450, which is basically give us ideas with a target, and 4,372 with the other version. Now, let me see if I can do this. I can annotate, but I'm not going to be able to do it. Hold on, I'm not going to do that. So essentially what we're looking at here is we're looking at a measure of how good these ideas are. There's three ways to measure them. The first one is how good the ideas are. And we were measuring here by purchase intention and novelty. A perfect score is a 10. And what you'll see is all of the methods generate numbers between 4 and 5. You'll see a statistically significant increase in the results from human beings to using AI to using the smart AI methods. But from a practical point of view, it doesn't make much difference. Sometimes statistics help, but what you want to see is you want to see things that make a dent in the universe, do something better. So from a practical point of view, looking at the quality of ideas, all very similar. The second thing we can look at is we can look at how different are the ideas. Just like in the original study, we use something called cosine similarity to measure how similar ideas are by different methods. And what we can do is we can take a statement, a phrase, or an idea and see how close things are to one another. So for example, in this case, this is a very happy person, and that's a happy person, tend to be pretty close together. That's a happy dog. Yeah, it's just somebody happy. And today is a sunny day is a lot further away. Basically, what you're looking at is how close they are. It's like a correlation. 1 means they're really close. 0 means they're really different. In this case, you want to have things that are really different. And what we can look at is, in our case here, human beings working on their own generated much more different ideas than AI did. So if we look at the general look, ideas are about the same, and human beings are more diverse. So what am I doing? Why am I looking at AI? What's coming up? So we looked at different ways to look at the data, and we came up with something that I think is really important. Is a basic insight, which is, do you really want 5,000 ideas? The answer, of course, you don't. What you want is a few good ideas. And what we did is we set up a bar in our study. And where did my line go here? We drew in a bar here, and we looked at the number of ideas that fell into the top 5% of ideas. Or what's the 95th percentile? And here the numbers are completely different. Human beings hit one top idea about 1% of the time. Human beings working with AI got better, hit about 1.5. Human beings with a clear target in AI got almost double, but with these smart tools, you got somewhere between 5 times and 8 times more ideas. Now, I want to make something really, really clear because it's really important. It's easy to get more ideas with AI. What we're talking about here is not just more ideas, but significantly better quality ideas. We're talking about the frequency of good ideas. And what we're looking at is we're looking at somewhere between 2 times and 8 times more good ideas. When I work with companies, we talk about what is the future. The future is not human beings or AI alone. Neither one is a clear winner in the area of innovation. If we look at human beings plus AI, they will get better on creative tasks, but they'll make failures on critical tasks. The challenge is to put the two together in a way which is smart AI. And smart is about predefined tools, knowledge on how to use the tools, and knowledge on how to interact. You bring the two together and you can get wickedly fast. You can get better ideas. It allows us to do things, as we'll talk in a bit, be able to run a 5-day sprint in 2 days instead of 5, and get 2 to 3 times as many ideas. Now, one of the smartest ways to use AI is to use a proven methodology called TRIZ. And Richard's going to tell you about that.
Thank you, Bryan. I'm going to give you a brief history of TRIZ. I know some of you out there are very much familiar with TRIZ and have a lot of knowledge, but maybe there's a few of you that aren't familiar with TRIZ. So basically, TRIZ started with Heinrich Altschuler, a genius inventor himself, back in the 1940s. He was working in the patent office, and he just was continuously being bombarded by people looking with problems that needed to be solved. Altschuler wanted to help these people, and he came up with the idea of developing a program by which he would review the patents in his patent office where he was working, which was a local resource, and work with the patents to extract information and synthesize that information and then catalog it. And upon experiencing, as he was going through this process, he was amazed that a lot of the ideas that were found in different industries kept recurring over and over and over again in different industries. That wasn't a visible or an obvious pattern for people to understand. This empirical data, and this part of empirical data is the part that drove me to TRIZ, because it's not psychological babble. It's something that we can quantify and measure. Whoops.
Okay,
what happened to our slide here? Hello?
Yeah, it's coming back.
Okay.
So no
Anyway, it's something that we can quantify and measure. The statistics showed that.
Yeah. Sorry, it's gone away. It clicked on something, and nope, boop, boop. I promise you'll be back. Keep on going, Richard.
Okay. And he found that about 97% of the problems that were solved in other industries were fathomable or were findable using the principles of TRIZ and the parameters by describing the problem in the context of contradictions. So out of his studies, we have 90% of the solutions were solved by using the principles. I'm sorry, got discombobulated with the slides here. Next. So we have, what is TRIZ? So TRIZ is inventive principles, principally, as a major tool that is well known by a lot of people. Usually that's the first thing that most people get introduced to when they start studying TRIZ. But it's also other tools and methods that are used for solving other kinds of problems. But overall, TRIZ is a technology for innovation, creating new systems, for developing existing systems, and solving subsequently related problems. Next. So let's get to the quick, how do we solve problems? Well, if you have a problem and you know the answer to it, there is no real problem. But if you have a real problem and the answer is not readily known, what do? I hope you don't use brainstorming, but I know a lot of people do. That's the first thing that naturally comes to mind. They just start guessing. They don't really base anything of that on something that's systematic or transferable or reproducible. Research tells us, according to Altshuler, that many problems have already been solved before. Altshuler had a very succinct way of developing a system for solving contradictions, and this was derived from the way that he extracted information from the patents. Was he took the my problem and he converted it into a generic problem. The tools that he used were parameters, and something happened to that slide. And those parameters describe the problem, but not specifically to the industry, but just as a generalization of the problem itself. Then he cataloged the principles, which were the generic solutions, and those were the 40 principles arose. So when you have a pair of contradictions, a pair of parameters that are in contradiction to each other, they point to a group of inventive problems, 40 principles, that can be used in order to satisfy the problem at hand. And the way I do it, I usually generate several contradictions and look at all of the inventive principles that are there. Principles like segmentation, principles like nesting, principles like do it in reverse or self-service or copying or changing the color, homogeneity. Very, very helpful and very, very explicit pointers to losing your solution. And this is where AI is able to pick up. AI knows all of these solution concepts, and is able to infuse those into developing ideas for your particular solution. Why is TRIZ useful? Well, most problems are not unique, but rather variations of problems that have already been solved before. You know that they work someplace else. Next. TRIZ is powerful and comprehensive methodology, but it's messy. It's confusing for beginners. If you look at this TRIZ roadmap here, you find that you can get lost very easily between all the tools and information that's available on there to solve many different kinds of problems. But we don't need to know all of these problems. We don't need to know everything about TRIZ in order to be able to use it. Fundamentally, we can look at a segment of TRIZ and be able to plug that into AI and be able to generate some solution concepts for our own. Next. Okay. Sorry, this is a slide I was talking about. We don't have to go through that rigorousness of developing contradictions. We can just tell our story in very detailed format and give them the parameters of the story and let AI figure out what are the contradictions that they can be used in order to apply the TRIZ principles. Specific and factual, and generate use some specific and factual solution concepts. Next. I'm sure all of you have heard about the Pareto principle. Well, this slide has changed again. So if we apply 20% of learning about TRIZ, we can get about 80% of the results that we're looking for the majority of the problems that we're looking at. And most of the problems that we look at aren't very sophisticated or high-level problems, but are very casual problems that we can solve, but they're still difficult. There are problems that we would spend a lot of time pondering over and trying to figure out how to go about solving that individual conundrum that we're dealing with. So with some knowledge of TRIZ, we can move forward. Next. Next.
I've just done the next one for you. Think okay.
Pardon?
I did the next one. Okay.
Okay. So some of the methods of TRIZ that we can delve into are the problems in the matrix, substance field analysis, ideal final result, evolution trends of engineering systems evolution, or engineering trends. 9 windows are all different methods that we can use that have different purposes within the TRIZ methodology. But if we learn just 20% of TRIZ, just the principles and the contradictions, we can accomplish a lot without having to learn the other 80%. The more familiar you are with TRIZ and TRIZ methodology, obviously, the better off you're going to be. The more practical you'll be able to implement TRIZ in your solution finding expeditions. Next. AI has been trained to solve many problems. AI has got much more data to be able to examine and to bring to the table when it comes to solving problems. When Altschula developed his system, he only used about 40,000 patents in order to develop the TRIZ methodology. But with AI, you have almost an infinite number of data points to be able to bring to the table, and it's exponentially increasing every day. Applying TRIZ to a specific problem, identify the problem itself, identify the core problem, make sure you understand it, and what do you want to come as an outcome. The next thing we do is search for ideas based on each method. Okay, generate a range of potential solution concepts, and then look at what we want to improve on each one, extracting those that are frivolous and concentrating on those that have promise. We want to review the ideas and generate, again, assessment for feasibility and refine the solutions as needed. Basically, that's the best for us. So we're still going through that cycle of taking your problem, turning it into a generic problem, looking at the generic solutions generated by AI, and then using those best solutions in order to apply to the problem at hand. Next. When we use AI and bring it into context, we have to clearly define the challenge, same process, but we write it up into the form that Bryan had put together, the True North form, which is very simple and easy to use. And the third step is ask for ideas based on inventive principles. And what I liked about using AI for this purpose is that you can put it in a context from different perspectives. You can change your perspective to meet the needs of the problem. If you try it one time and it doesn't give you good enough solutions, try it again. This only takes about 4 minutes to generate a set of solutions, and you can build a huge amount of data and ideas that you can support your project. TRIZ and AI can do a lot more. In the case study that we're going to present, you will see how we spent more than 4 minutes using TRIZ and AI. But the process is still the same. Define your challenge, check your solutions, and benchmark your ideas. It's a very systematic process that moves forward, works just the same way in most problem-solving methodologies out there. But TRIZ is very comprehensive and gives you the best chance of coming up with the best solution concepts. And that's what we want. We want good ideas, strong ideas, not 10,000 ideas, but 5 or 10 really good ideas. So the challenge, the problem or the challenge, and plus the inventive principles will give us a lot of ideas and targets. And AI is really good at generating ideas and targets, about 1 per second. God damn. Phones. But innovation is...
Yeah, that's me. So, but innovation is more than ideas, because it's about building, testing, executing ideas, and more importantly, bringing people together. And the idea, and the powerful idea to do this was through something called an innovation sprint, and that concept was created by Jake Knapp, and it became well known through his book. As you see here, it's called Sprint. So now let's talk about the design of the original sprint, which was from Monday to Friday. And during that sprint, on Monday, we defined objectives. On Tuesday, we generated ideas. On Wednesday, we refined them and communicate. On Thursday, we build a realistic prototype. And on the Friday, we finally test them and systematically improve. So why sprints are so great? Because they are very easy to run, and actually you need they are great because they focus on testing. So they disrupt the silos in the organization, and they are very focused on one challenge at the time. When conducted properly, they also help to reduce the risk. And actually, to run the sprint, you need three things. And it's the length of the sprint, the expected deliverables, and the process to ensure that. And actually, anyone can lead the sprint. You don't need very much experience with that, because there is a lot of materials on how to do that properly. And great thing, because even when they are run poorly, they tend to bring the positive results. At the end of this event, there will be also a link that provides you with materials how to run it. So they are great, but they could be better. And actually, we addressed the key issues, which were that they are often run to solve the wrong.
Let me ask you a favor. I'm looking at the time, and we're going to run over time, and I want to make sure we cover things in the time available.
Yes.
How about if I do the things from here up until the end so that we get this done on time so people get, is that okay for you? I don't
Absolutely.
because I know the slide's coming up, so we can skip a little bit of this. So sprints are fantastic. They do amazing stuff, getting people to do things more effectively. But the biggest issues is if you're solving the wrong problems, you don't get things done. They can take too long, they're too hard, they're too this, and getting people away in a business for 5 days in a row is a lot of work. Something that we've done to work on that is we've started putting AI into the innovation sprint. And we've taken a toolkit which takes people through basically the same steps that people do in an innovation sprint, but augmenting it with AI along the way. What we do is we say, look, we have the basic format of a sprint, and we're putting things at each stage along the way. And I'm not going to go through each of these to go through it, but basically each step along the way, you try to take AI and make things better than it was before. And what we've done, which is, I think, very cool, is we've taken a 5-day sprint, squished it down into 2 days, and we've added something else which is there, which is something we'll call soak time, which is, you know what, when do you come up with a good idea is when you take time away. So what we have is a 5-day sprint being run in 2 days. We have time off to think, and we add a half day to generate actionable ideas. And typically what we get here when we run the sprints is about 3 to 5 times as many ideas, twice the results in half the time. A question we had was, could TRIZ be used to make the process more effective, faster, and easier? And what we're going to do is we're going to show you something we did retrospectively, which I think is a brilliant idea from Richard, going into how we can do this. You're on mute, Richard.
Here's the project that we picked. It's a retrospective test of TRIZ on the Hoover Dam project, which took place in the early 1930s. The Hoover Dam project was a government project sponsored right after the Great Depression in order to jumpstart the American economy. It began in 1930. It's a huge engineering project, and what we wanted to do was to build a dam in Colorado to tame the river and provide hydroelectric power to the Southwest. So it was a worthy project, needed to be done, and they diverted the money and the resources in order for it to happen. In a nutshell, the biggest problem they had to start with was, in order to be able to build the dam, they first had to divert the river coming downstream through the canyon, and had to divert it through 4 tunnels, as we see here, with the dam in the middle. Each tunnel was approximately 40,000 feet, 4,000 feet long. Got no screen here.
It's okay.
And had to be built within 2 years because they needed time in order to finish the dam. At the current process of building the tunnel, they determined that the current rate was going to take them 4 years, the way they were doing it. So they needed a better method in order to run through the process of building these divergent tunnels. Next slide.
Okay, so the next slide we have is a video, and it's going to tell you about the challenge. I was putting the sound on, so it would play.
Oh, okay.
Crow sent miners down the river to start the first and most dangerous phase of construction, the 4 diversion tunnels, 2 on each side of the river. Work crews would have to drill and blast 3/4 of a mile through the canyon walls to open the holes that would carry the river around the work site. 56 feet in diameter, they would then be lined with 3 feet of concrete.
Those diversion tunnels were unique. To get them lined up, the job of drilling and shooting with dynamite, removing the rock, it was logistically one of the toughest things they did in the dam.
6 companies also had to contend with a rigid government deadline. 2.5 years to divert the river or face steep fines for every day they ran late. The volatile Colorado constantly threatened the job. In a flash, seasonal floods could wash away any plans for finishing on time.
So what we started with, and the challenge we talked about us together is, this looks like a tough challenge. Would AI be able to solve this challenge? Would AI with TRIZ be able to solve this challenge? And if you remember back, to our idea building phase, the TRIZ won in our idea building contest, and we've got a whole more TRIZ-based prompts. We figured, it should work. The only problem is it didn't. The recipe we had was essentially a clear objective and then asking TRIZ for ideas. We had a series of tools. We had an AI for innovation toolkit and a big prompt chain. What we did first, trying this out, is we did what typically people do, is they go over to ChatGPT and say, look, I've got a challenge, give me ideas. Remember back to what we're talking about, those ideas are typically not the most creative. In our case, we called it the Nike solution. We did a fast description of our challenge. We ran a bunch of TRIZ tools. We got lots of good solutions, but little that was on target. This is the most common error we all make when we're using AI. We said, okay, look, you know what? Maybe it's an issue about the quality of our targets. So what we'll do is we'll try to develop more information about our targets. We'll use the TRIZ prompts again. We looked at the results that came back, and we sort of danced around the solutions. An expert tool in terms of using AI is you can ask AI about how you're doing something. We asked AI to say, look, this is what we're doing right now. We're running TRIZ in bulk. We're not getting the results that we want. How could we improve this process? And it gave us back some ideas and suggestions on how to use TRIZ in a more iterative fashion. And we tried that out. The iterative fashion is basically more give and take, more talking back and forth. And remember, we talked before about chain of thought. The idea is asking the AI to improve the ideas. So we had better targets. We had iterative AI. We got a higher hit rate, but we still weren't there. We looked one step further and we said, you know what? What's happening is we're not getting specific enough solutions. So we gave the AI the context that you had to provide solutions to things with technology that existed in 1930. We went in and looked at sub-targets, the things that made this work, and with a lot more detailed targets, the iterative AI, we got to what I'll call a bingo. So let's talk about what worked. And here, I think for the people that are using TRIZ, this is the most interesting thing. We ended up using a step-by-step process. That step-by-step process was essentially a change in what we were doing. Step one, we started with an objective. Step two is we didn't go straight to building ideas, but we looked to see how can we understand this problem more effectively. We then updated our objective, and then we used TRIZ and other TRIZ tools to do things in an iterative fashion. If we look at the process we ran a series of 13 prompts, going through things step by step. In a best practice, what would happen is we'd have a lot more human review. If, building this dam was really critical to our lives, rather than doing a case online, we probably would have done it, but we didn't do that. Now, if you want, you can get access to the prompts by filling back a feedback form. You'll get all the prompts we run. You'll get access to our toolkit. You'll get access to the different prompts in something called Super Chat. You'll also get them in an Excel sheet. But let's talk about how we did this step by step. Step number one, we defined our challenge. As we talked about, give it a story, give it objectives, give it constraints. Step number two, and this is probably the biggest thing, and I'd say the biggest impact of TRIZ in the process, is we actually did a functional and ideality analysis to clarify our challenge. If you can imagine this, what we're essentially looking at is a series of key questions. Working together with AI, the first question we had is, what are we working on? Secondly, can you define, for example, what has to be done to build a diversion tunnel? Understand the challenge. Help us estimate, the time spent on each step. Focus us, and let's see if it worked. No, it still doesn't work. Focus on the most important things. Create some ideal solutions. And in those ideal solutions, what we end up with is paths to go down that'll get us in the right direction. Essentially, if we took all the things with 1930s technology and did all the things as good as we can with the ideas that came up with TRIZ, we saved approximately 30% in terms of time. That's not enough to get there. What we did now is we said, look, we have all this information. How can we get much better in describing what we want to do? Essentially, what we did is we took our initial objectives, were much more detailed, and we gave AI a lot more ideas to start. Then we used iterative TRIZ and AI. This process wasn't very complex. The first one was essentially use the TRIZ inventive principles to generate 80 ideas, 2 for each of the inventive principles. Prompt number 2 is, you've got 80 ideas. What we'd like you to do is to merge together different TRIZ methods to make combinations of ideas. So combine methods to make combinations of ideas. And this is the first part of the iterative process, is saying, look, we have the 10 strongest ideas so far. Identify another TRIZ principle or way we could improve. Back to what I think is my favorite idea mission, is creative combinations, which is not part of TRIZ. What we looked at is saying, look, can we take related stimuli, mix and match them together to give more ideas? So we ended up with 90 more ideas. What this looks like in practice is we have a list of stimuli, another list of stimuli, best ideas, put it all together. We ran a chain of thought again. So give us the 10 best ideas, improve them step by step. Lastly, we went through a process of evaluating the ideas. We're just going to hit this on time. What we ended up in the process here is we ended up with 266 detailed ideas. That led to 10 top ideas, to a final merge solution, which we're going to present in just a second. We're going to run about 10 minutes over time. There will be time for questions and answers. If people have to leave, we won't be offended, but I'd like to go through the rest of the presentation so that you can see the stuff that's there.
Brian, there are a few questions about the recordings, so it will be shared after the event, right?
Everybody gets a copy of the recording. Essentially, what we've done in this process is we talked at the beginning, how do you get AI to work? You take domain expertise, you take innovation expertise, and you take AI expertise. Domain expertise is built by understanding the challenge. Innovation expertise is about applying innovative methods. And AI expertise is about using AI not just as a search, but working together with it. What we came up with, or what AI came up with in its 40 minutes of work, was a solution. The visual here is drawn by AI. It wasn't drawn by me or Wojciech. So it's not the most perfect thing. They said, we want to build a Steam-based solution with a fixed scaffolding, multi-level. It's pre-made. What we would have is at each of these levels, we'd have room for drillers to set down the dynamite that they have to do. It would be used for drilling and also for removal. And we would have pre-built supports. Now, this is what AI came up with in 40 minutes. Let's show you what really came out.
An almost comic contraption turned out to be Frank Crow's best weapon against the tunnel deadline. The steel and wood beast, called a drilling jumbo, carried 3 tiers of drills on a 10-ton truck. The rig was backed up to the face of the wall, and the 30 drills bored holes into the rock to plant dynamite. The jumbo could then be pulled away for blasting, and the whole operation moved to the next drilling area.
That was a pretty clever idea, because before they'd have to put up staging. Then the staging would have to be taken down when they blew the face, and then they'd have to replace it. It was a big time saver.
So looking at this, what we didn't show is AI is a solution by itself. What you need is 3 types of expertise: domain expertise, innovation expertise, and AI expertise. TRIZ as a tool is quite effective because it structures your idea. It forces you to get better understanding of the problem and the solutions that are available. It allows you to generate solutions that are known to work. It's effective, easy, and fast. It's a lot like we talked about earlier, which is smart AI. Now, what we look at is how can we put this back in the innovation sprint? Essentially, and I'm not going to go through this, it's primarily at defining the problems and defining how to identify the challenge more effectively, but TRIZ is also very good at generating the solutions. What's most important here is TRIZ with AI is effective, fast, and easy. With just a few pretty simple prompts, you can get started. Give me a challenge, describe a challenge, ask TRIZ to come, use TRIZ to solve that challenge. To be honest, you don't need us, but we can make the process easier if you want to use TRIZ in your AI projects. What do we offer? We've got innovation expertise, TRIZ expertise, sprint expertise, AI expertise, a desire to make things happen, and people have told us we're fun oftentimes. Where you can go next, we do trainings, we do certification, we run sprints, we do a la carte stuff. And some of you are asking if you can get the slides. Slides are available. Wojciech, if you can put that link in the chat.
Yes, of course.
But more importantly, you can get lots of free stuff. You'll get more information in the case study. You'll get a copy of my book Cycles. I don't know if anybody wants it or not. You'll get the webinar slides and video. You'll get the TRIZ prompts, and you'll get 100 and some pages of AI output, which were used to solve this challenge. And now, what I'd like to end with is an opportunity for people to ask questions. I know we're a little bit over time. If you have a difficult question, I'd like you to ask it to Richard or Wojciech. If you have an easy question, I'll do my best to answer it. And you can type them in the chat if you want. I've been struggling a little bit to follow the chat.
Much has been put in. Oh, wait a minute, maybe more.
So knowing how hard it is to ask a first question, Would anyone like to start with the second question?
I've seen one question in the chat from Robert. It was about, I don't know if it's already explained. Robert, are you still here?
Yes, I'm here.
Yeah, pleasure to see you. So, did the explanation in the presentation was the answer you were looking for?
No, I was looking for how you implemented the inventive principles, because normally what the TRIZ people do, they just ask for the inventive principles and they just get, so to say, the headline of the inventive principle to be applied to the solution. So we had a group in Germany which is called CC Top, which is Creative and Collaborative TRIZ Open Prompt Project. We just did a few shot prompting on those inventive principles so that we can come up also with solution for the sub principles. So that was my question about the inventive principles, because you just used an inventive principles there.
Yeah. So what we did in this I mean, there's lots and lots of different ways, Robert. And I think, the more that you know the methodology, the better you can use it in collaboration with AI. The way that we did it is we used the inventive principles first. And then what we did is a combination of different TRIZ methodologies along with the first ideas. And that ended up generating approximately 160 different solutions to the challenge we're looking at. And those ideas are pretty good.
Okay, good. But then I was probably just then, so how would those inventive principles then ask for?
Quite simply, we said, look, we've got a challenge. Taking into account all the things we've been talking about before in this chat, generate 80 ideas based on the TRIZ inventive principles. For each of how we do it is we want you to generate 2 ideas for each of the 40 TRIZ inventive principles.
Okay, good.
That one magic prompt will give you 80 good ideas to almost any innovation challenge you're facing.
Yeah. Well, if you could have also better results if you include the sub principles there.
Yep, I agree.
And even if you go then for the different principles, there are principles that more deal with materials and stuff, and others that with the timeline. So if you switch to those, then you even also can improve the situation. So just as a hint, it was our experience.
No, but I think you're very spot on, because in fact, what you're looking at is the power is the iterative process. How do you make ideas better and better? So for example, we found when you just asked this question straight up, it didn't give you very good results. But if you looked into digging into more of the sub principles, you got much better results.
Yeah.
Which is, I think, the same experience you had, Richard, when you were using AI.
I just asked it to use the principles to begin with, and it gave me a list of, I don't know, 20 or so ideas. And then we refined it a little bit using functional modeling, and gave it additional parameters of how much time was taken in each step and what steps were necessary in order to accomplish the job. And then it gave me 8 very good ideas, I thought, in every aspect of the process of drilling the tunnel, from getting rid of the rocks, from the building of the scaffolding and the taking down of the scaffolding and the drilling and the blasting. It gave different parameters for how to handle each one of those functions, those sub-functions within the functions of building the tunnel. So I thought it worked very well and was very simple. I'm not an expert in AI, and I don't pretend to be, but I hope to learn more about it and to be able to use it more effectively.
So Robert, I think.
Robert?
Go ahead.
Is that good for you?
I want more, Richard.
So,
how have you been?
I just sent you a link to a GBT that we did on that, and when you ask this GBT to apply inventive principles, it also uses then the sub principles of it.
So I see Johan here with a challenge. Actually, I've done trainings, trained people on how to use TRIZ, and they walk out and say, "Oh, this is fabulous! I'm ready to go." And then they get off on their own and they get stuck and they don't use it again. And what Johan is saying is, I was taught to create a functional diagram and then a contradiction, and then I was, you know, basically it gets very complicated. Now, the advantage of using AI in the process, it can actually think on your behalf through a lot of the process of TRIZ. It gives you a shortcut between the 2 points. And the shortcut works very well. Robert, what I would go ahead.
If I was having problem developing a functional model of a system, the stumbling block is that you just don't know enough about the system. You need a subject matter expert to help you develop the functional analysis or functional model and be able to dig into it. As a TRIZ person, you're not a master of all industries and sciences. You're a facilitator of TRIZ methodology. So you still need your subject matter expert in order to help you get through a project or developing a good functional model that works, that's accurate. Hope that answers your question. A lot of students get trouble developing a functional model, but they need time, they need expertise, they need to keep working the process. They can't give up.
Arzul, you have a question.
Oh, I got two questions. Yeah, the problem every day we face actually. So first one is how do we use interest to, the emotional point from the human being when making the decision actually. We need to know actually that the people making the decisions actually we need to know everyone, the people making the decision are they in a good, what I mean actually, because yeah, it's no one ever asked actually, yeah, because there are five people teams actually when we taking the decision actually, so we need to know everyone is really in a good thought process or good mood. So it's really important one, my feeling actually. So we need to know because some people may be tired or they got a personal issues. When we take the decision in these kind of situations, I don't think so we get the really good decision. So how do we, is there any kind of process in the trust support?
I think it's called caffeine is the process, Arzul. So I think, what you have is you of course you have human dynamics that comes in.
Yeah.
The one thing that's cool about AI, it's like this little busy assistant and knows everything and remembers everything and never gets tired. So you can do an amazing amount to support any team making decisions, analyzing things, and bringing stuff faster and quicker than you can as a human being, as a group normally. And what I see, it takes off some of the drudgery work and it makes everything faster and easier. And when things are faster and easier, people have more time to think about the stuff they have to think about.
Yeah. So the second question is mine actually. So when we do any work, any task, and we working on it, I think people start recording the descriptions. A lot of stories.
Yeah.
So, but actually, what I want is like a metrics because it's yeah. The one problem yeah is fine actually if you start writing the stories. So what you did or what things, but what actually I want is a metrics for each the story they write. So
what you're looking for, let me cut you
the
up.
metrics is the numbers actually. I don't want anyone to write, a paragraph of stories because the lessons learned ever yeah it cannot be captured in the future actually. So how do we? I want really like a number systems to tell me actually. For example, any task done on the particular date, particular time is the success rate is, you know what I mean? So the number systems to tell me because the way we do it as a start, the system is the current system has got a lot of stories. I've done this topic they should.
I'm going to cut you off here because I'm
Sorry.
actually I'm not seeing the direction where your question is going.
Yeah,
So
sorry. Yeah.
I think what you're looking at is how do you support the process and how do you make the process run more smoothly?
Yeah.
I think what you need to do is you need to have effective metrics in place to evaluate ideas before you start. And that's a human process. That's a human process of defining that. And I think what you can do is you can use the AI to help you structure, analyze, and do things more effectively. One of the things we did here is we gave specific metrics to evaluate the ideas, and that works pretty well. If you want, send me a message, and I'll be happy to follow.
I'll send you the details message. Yeah, I'm sorry, I can't explain in the meeting actually.
Okay, so we have one last question, which is Ram. I love the name Ram. What a great name.
Thank you very much, Bryan. Can you hear me?
Yes, we can hear you.
Yeah, I am the VP of Innovation. I've been working on TRIZ and Lean Sigma for almost 25 years and also Sprint. But this is really, with the presentation, the way you combined all the tools and techniques is just fantastic. And another thing, it answered the very important question. AI is going to take away jobs. No. AI is not going. We need to have domain expertise, AI expertise, and solution expertise. Otherwise, it is not. I think our jobs, people's jobs, are safe as long as they're willing to think. So this is fantastic. But I'm really excited about this. And TRIZ was, people are very slow in taking it, but TRIZ plus AI is going to put TRIZ on the steroids again. Instead of, I've been working with TRIZ, but intake is very slow. And so that is, I'm very excited and it's wonderful. It is just a thanks. And another important thing I want to leave with this one is for the metrics, as well as for evaluation, we have something called the Pew matrix. You may already know that one. We can use a Pew matrix to generate the ideas, and then focus the ideas, generate the ideas to come up with that one. We can also assign metrics to Pew matrix, Pew matrix, MATRIX, and then we can use a Pew matrix to refine our solutions. This is fantastic. Thank you for doing this free.
All right. Thank you, Ram.
Richard, could I ask you to close out our session with something you talked about earlier, which is about the S-curve of AI and TRIZ?
Well, this is something that got me interested in working with you, Bryan, is the fact that, why is, and Akesh asked the question in the chat box was, why hasn't TRIZ been more readily accepted in the world and given its proper due? Excuse me. It's because, I think the way TRIZ has been taught is the way that Altschula developed it over many years, bits and pieces here, and continually evolving it and moving it forward. But with AI, our knowledge base, the database of knowledge that's being accumulated in the cloud, is just growing exponentially year after year after year after year. And there's no way that we could put down on paper and be able to resource all of the activity and the information that's being gleaned and developed over time. Coupling AI, which has got the ability to capture that data and link it to the topic at hand, or to the challenge, or to the problem, or whatever you want to call it, I think is going to greatly influence the way TRIZ is applied. And, I believe the TRIZ is the very strongest problem-solving mechanism that's available amongst all the other methodologies. It complements virtually every other methodology and makes it stronger and gives you better solutions. But, the next S-curve, the next evolution of TRIZ is very, very important. And I think this is what's going to happen over the next 5 to 10 years. It's happening now. But people have to move forward and learn a little bit about AI and continue to study and improve their capabilities of using TRIZ.
So for me, my experience is I can teach a CEO to use some basic principles of TRIZ in 10 minutes with AI. Before, that took me a day to a week. And when you can start using those things in 10 minutes, people start using it and they see the value. And then people are going to dig into it and they're going to learn more about it. They're going to use it more. So I think this is really the opportunity going forward. what I was going to suggest here, I see Ken still has a question, and I know a lot of people are very polite, so they stick around and they don't want to leave and things like that. I'm going to offer Ken will stick around to answer a question if you still have one. If anybody wants to go, we won't be upset. We won't be sad. Of course, we'll be sad, but
Such great content, Bryan. We guess they're just mesmerized.
Okay. So if you want to take off, don't feel bad. You'll get a copy of the slides, copy of the video. What I do ask you to do is to fill in the feedback form, and then you get all the prompts that we've run, and it's really cool. It's really amazing. I think you won't be disappointed. So Kent, I'll let you ask your question.
Yeah, no worries. One thing that I find interesting, I'm using a lot of AI. I've been using the ChatGPT before it actually got released. But anyway, what I find interesting with using it for TRIZ is more looking at very hard problems, where you basically start stating what is the main problem and how can you solve that contradictions. What kind of way can you go around it with the contradictions and the suggestions it can come up with. But you need to do some scripting in the background to get the program or the AI to understand how this the different parts of TRIZ is actually working together. And when you get that in place, you can get a very strong tool, that's for sure. But I still think there's a lot of work to be done to get the AI to really understand and being useful for using TRIZ in the right way. But it's most definitely one of the best tools. So my question is, what is your software or your programming behind the setup you are doing? Are you using general AI as ChatGPT GPTs, or are you making it from scratch, or how are you doing?
So the toolkit that we have running the AI prompts is programmed in Python. We've tested it with Gemini, we've tested with Hugging Face, and we've tested with ChatGPT. The best is still ChatGPT in terms of finding innovative solutions.
We tested with Claude, also Anitropic.
Yeah.
But still GPT is winning.
And
yes.
And I think, we've also started doing a lot of things in terms of interactive GPTs, because in fact, the biggest issue in the future is not going to be to create ideas, but to define the problems.
Exactly.
And what you can do is you can set up a GPT which actually interacts with somebody, and they're digging deeper and deeper and deeper to find the problem. And my favorite book on innovation is really old. It's called Stalking the Wild Solution by a guy named Arthur Van Gundy. And he says, look, essentially, if you find the problem, the solution's almost 90% of the way there. And I think that's the opportunity. And that's where TRIZ really shines.
Yeah, I feel it's about, if you have a hammer, everything looks like a nail. You need to really understand the problem before you actually dive into TRIZ and how to use TRIZ. Because if you don't understand the problem in the first hand, TRIZ will give you anything. So that's what I see.
But that's actually the first thing we did wrong, Kent. We said, look, let's go. And we did exactly what we tell people not to do. So
exactly.
we're clever guys, but we still made the mistake.
Exactly. But have you tried using TRIZ or try to use the AI and make several agents and let them work together on a problem? We
are doing that right now.
Yeah, because I've tried. I'm trying doing that, and it's quite amazing if you program it right. It can actually find very novel solutions to quite difficult problems also.
Perfect. So Ken, what I'd love to do is I don't know if we're connected or not, but if you're not, connect with me, and I'd love to share with the tech stack we have. You can share your agent stack. Richard, can you end with words of wisdom? Because we're going to end this here.
Yeah.
And you're the wisest.
Words of wisdom. Well, TRIZ and AI is a perfect match. AI is going to continue to evolve and improve as time goes on. Dramatic changes are being made in hardware, and dramatic changes, I'm sure, will be made in software. And this will continue to perfect itself as it moves forward. So I look forward to great things happening in the future where we can accelerate innovation and creativity, develop new industries, new products faster and better, and create a better world for everybody.
Those are good words to end on. I'd like to thank everybody. Wojciech, do you have a last thing that you'd like to add?
A lot of people asking about, I believe it's how do you verify or filter the solutions or the stuff. So basically what wasn't very deeply described because of the time limitations, there is a great tool that Bryan showed me about formulating challenges, which is called the True North Challenge. And to answer, I guess, 4 questions from the chat at once. So how do you verify a lot of ideas that AI is generating? Is that you ask both AI and you do it by yourself, by a human verification at 3 times during the process, how the ideas meet the challenge that is clearly formulated at the first step. And I hope that answers the question that was left there. So True North, remember.
So the really amazing part there is when you define your objective clear, you can ask AI to evaluate 1,000 ideas against that objective in 10 minutes. And it's truly amazing. All right, that's it, everybody. Thank you. I appreciate it. And everybody who's here, if you send in the feedback, you get a copy of the slides. Sorry about the technical hiccups today, but stuff happens. Thank you.
Thank you. Cheers. Bye.